Alright, my little math friends, here we are moving on to our second lesson here in chapter 13. 13.b. Now we're going to be looking at theoretical probability of compound events. Okay, we did the last one by we calculated the last ones by using a table or a tree diagram. Okay, and you can use those. Sometimes you can't though, and we have to go with something else that we're going to talk about in this one. Alright, so finding the probability of more complicated situations, that's what we're going to look at. It's going to be all about being organized. Okay, it's not going to be extremely difficult to do, the math-wise anyway. It's just about being organized. And what we're going to be doing is we're going to be creating lists. Because sometimes you can't use a table or a tree diagram, you just have to make a list to figure this out. And we're really just going to be crunching some numbers. Okay, is what it is. Number crunching. Alright, which is coming up with a bunch of different numbers, a bunch of different possibilities. So let's take a look at our first situation and we'll check out some number crunching while being organized at the same time. Alright, so here's our first thing. The combination for Keem's locker is a 3-digit code that uses the numbers 1, 2, and 3. Any of these numbers may be repeated. Find the probability that Keem's randomly assigned number is 222. Okay, so we're trying to figure out what the probability of having that combination of 222 for his locker code. Okay, so what we need to find, step number 1, we need to find all possible outcomes so that we can predict the probability. We need to know how many different combination types are there for his locker with this 3-digit code. If we're using 1, 2, and 3, and if any of them can be repeated, how many different possible outcomes, how many different combinations do we have? Okay, so that's what we're going to find out. How many combinations do we have? The key is to stay organized when we're making this list. Okay, so here's what I'm going to do first. I'm just going to start with 1. So he could have a locker combo that would be 1, 1, and 1. Okay, that could be one possible combination. Alright, if we stick with this same pattern, if the first number is 1 and the second number is 1, he could have a locker combination where the third number comes out to a 2. Alright, we could also go with the very next one. Both numbers could still be 1, and the third number could be a 3. Alright, then this would be all the possible combinations, all the possible locker combinations there could be if both the first two numbers were 1. Okay, so now let's move on to the next one. Let's keep the first number 1, and let's make the second number a 2. Okay, and then the last number, the first option we could have for a locker combination would be 1, 2, 1. The second possible locker combination could be first number 1, second number 2, third number 2. Then we could also have a 1, 2, and a 3. And that would be all my possible locker combination codes if the first number is a 1 and the second number is a 2. Okay, so that takes care of all these so far. Now let's just change the second number. Let's keep the first number a 1, and let's make the second number a 3. So if we're starting with the same pattern, the last number could be a 1. Okay, if we keep the first number and second number the same, the last number could be a 2. And then if we keep the first number and second number the same, the last number could be a 3. Okay, so that's all of our possible choices for a 1 and a 3 as the second number, and we've listed all the possible choices as having 1 as the first number. Okay, so now I'm ready to change my first number, and I'm going to go to the next number in order. I'm going to go with 2. So I could have a 2, and then the second number be a 1, and the third number be a 1. Then I could also have a 2 and a 1, and the third number be a 2. I could also have a 2 and a 1, and the third number be a 3. And that gives all my possible choices for first number 2, second number 1. And then if I go and I change the second number, I could still keep the first number 2. The second number could go to the next number up a 2. Then it could be 2, 2, 1. We could have 2, 2, 2. And we could have 2, 2, 3. Alright? What we're going to do is we're going to list out all the possible combinations there could be. Okay, there is a pattern here. If you find a shortcut with a pattern, you can do that. I'm going to list out all the possible choices, so that way you always get it right if you do that, and then later on if you come up with a pattern, then you can. So you guys continue to list out all the possible choices. I'm going to do the same thing, going in the same pattern, the same order here, and we'll see what we come up with at the very end. Okay, so there's all the possibilities we could have, and I stayed organized the whole time. I finished up with the 2's, and then I moved on to the 3's. There's all my 3, 1 possibilities. Here's all my 3, 2 possibilities, and then my last one was my 3, 3 possibilities. Okay, so all the possible combinations you could have with this is 27 outcomes. Okay, 27 possible combinations for that locker. Alright, and if we look at this list, step number 2, we want to find the number of desired outcomes. Okay, so the one we're looking for is how many times a 2, 2, 2 shows up. And that only shows up one time, which is right here. Okay, so we're going to determine the probability now. We are ready to do that. And that is going to be one combination out of 27 total possible combinations. So that's our fraction. If we wanted to turn that into a percent to see what that would be, we could take 1 divided by 27. And when we do that, our percent would come out to, kind of rounds out to 0.4, 0.04. We could move that decimal point 2 places to get us 4%. Okay, so those are our probabilities. If you like fractions, it's 1 out of 27 chances of having that combination. Or if you like percents, you could say there's a 4% chance of having a combination of 2, 2, 2. Alright, so that's how you got to go about making lists when you get more complicated probability situations to figure it out. Alright, the key thing is just to stay organized. It takes some time and some thought to get these kind of all listed out, and that's how you go about it. Alright, thanks for watching this, guys. There's not going to be a try this question on this one because it takes a bit to get these worked out. So I'll save you on a try this question, and we'll work this out in class when I see you guys again, and we'll try making these lists some more and come up with some probabilities. Alright, see you guys next time in class. Thank you.